This presentation introduces the new and dramatic improvements introduced in VMware's vSAN 8. While VMware has consistently demonstrated leadership in the data center and cloud by making vSAN the premier HCI solution in the industry, our engineering team has not stopped there. vSAN 8 introduces new capabilities that are some of the most significant since its debut in 2014. Let's take a closer look. To better understand the improvements introduced in this latest edition of vSAN, let's take a step back to understand how technology, the industry, and our customer needs have changed. Let's revisit the state of the industry a decade ago, when vSAN was originally being developed. At that time, spinning disk prevailed as the dominant media type for shared storage through 3-tier and emerging hyperconverged architectures. While NAND flash devices existed, they were relatively small in capacity, with their performance hampered by the legacy bus protocols they used. Networks were commonly just using 1 gigabit or 10 gigabit Ethernet in a core distribution access architecture. All of this was powering traditional VM workloads using modest resources and largely limited to on-premise data centers. The hardware of today looks very different. NAND flash devices have increased dramatically in capacity while dropping dramatically in price, especially with the introduction of QLC flash. These devices are often using a high-performance NVMe bus protocol to unlock the capabilities of the devices. Networking of today is often using 25 gigabit, 40 gigabit, or even 100 gigabit interconnects in a spine leaf technology and extending into new high-performance protocols such as RDMA over converged Ethernet. Workloads in these environments are commonly comprised of sophisticated multi-tier applications powered by large resource-intensive VMs and containers. These environments are often using data services such as encryption and space efficiency features to meet ever-increasing levels of compliance and value. And finally, the demanding workloads of today can be found running not only in the core on-premises data center, but the edge and in the cloud through offerings such as VMware Cloud on AWS, Azure VMware Solutions, and many more. This evolution in the data center has changed the equation for our customers and for VMware. First, bottlenecks have shifted away from storage devices to other parts of the data center. Performance, space efficiency, and security have also become table stakes for customers large and small. And as our customer environments grow more sophisticated, so do their needs, such as using snapshots for complex copy data management workflows, and always-on data services that offer security and space efficiency. While the complexities in requirements may have increased, so is the need for simplified consumption. These changes present new opportunities for VMware. We recognize that with careful examination, we could incorporate an optional, new hardware-optimized architecture with vSAN, while keeping the large majority of the code base that is making it the industry-leading HCI solution with well over 30,000 customers. This would give our customers all new levels of performance, scalability, resilience, and simplicity, all using the software that they already know. This leads us to vSAN 8, where we're introducing the revolutionary Express Storage architecture. This is an optional alternative storage architecture to the vSAN original storage architecture, also found in vSAN 8. When running on qualified hardware in approved vSAN ready nodes, the vSAN Express Storage architecture offers supreme levels of performance, scalability, resilience, and data services without compromising performance. The vSAN Express Storage architecture unlocks the capabilities of modern hardware to allow the workloads of today and tomorrow perform as the hardware allows. vSAN 8 represents a significant step forward in the capabilities of public and private data centers. The newly introduced Express Storage architecture allows customers to provide a platform that serves and stores data faster and more efficiently than ever before. But of course, it's not just about performance and efficiency. It's also about having a platform that demonstrates the agility needed to support a variety of use cases while making sure it's easy and intuitive to deploy, operate, and optimize. You may be wondering, how does the vSAN Express Storage architecture compare with the classic storage architecture of vSAN? At a high level, the original storage architecture of vSAN was a 2-tier architecture designed to accommodate a wide-ranging set of older storage devices, while the vSAN Express Storage architecture in vSAN 8 is a single-tier architecture optimized for high-performance NVMe-based TLC flash drives for both on-premise environments and for public cloud hyperscalers. With vSAN 8, you have the opportunity to select which architecture best suits your existing hardware. while allowing you to deploy new clusters with unprecedented levels of performance. While vSAN Express Storage Architecture is the future of vSAN, VMware customers should take great comfort that the original storage architecture of vSAN can be used side by side with the ESA and will be supported for many years to come. vSAN allows your environment to easily accommodate new clusters that are built for the ESA while coexisting with your other clusters running earlier versions of vSAN or existing clusters that have been upgraded to vSAN 8 using the original storage architecture. To do so, ensure that a new cluster is using vSAN-ready nodes that are approved for use with the ESA. Assuming that the appropriate licensing is in place for the new cluster, workloads can simply be vMotioned and storage vMotioned over from a vSAN cluster running the original storage architecture to the new cluster running the ESA in vSAN 8. Just as with past editions, the vCenter server can manage clusters at different versions, which allows for you to transition your environment at your own pace. Regardless, VMware encourages all of their customers to upgrade to vSAN 8, even when remaining on the original storage architecture. This upgrade will introduce vSAN enhancements to the original vSAN architecture, while customers become familiar with their opportunities to introduce the vSAN ESA into their environment. Now let's take a closer look into what the vSAN Express Storage Architecture is, and how it delivers all new capabilities for environments using modern hardware. So what makes vSAN Express Storage Architecture found in vSAN 8 so unique? We'll be looking at that in more detail throughout this presentation, but its capabilities are best captured by a quick summary of benefits it provides for our customers. The vSAN ESA provides a new way for vSAN to process and store data efficiently. A new fast and efficient data path paired with an efficient and resilient data structure give our users the ability to store and access data fast and efficiently. The Express Storage Architecture also provides an all-new snapshot engine that meets high levels of performance and scalability while remaining fully compatible for use with our ISV partners who provide backup solutions. And finally, the vSAN Express Storage Architecture makes administering an environment simpler by improving how devices contribute as a storage resource to the cluster. Does this mean that vSAN was rewritten? Not at all. As we'll see in the following slides, VMware was able to introduce some new technologies into this optional architecture. But that optional architecture is built within vSAN, the same software you already know. There are many aspects of the vSAN ESA that make it the platform of the future. We'll be looking at all of this in more detail shortly, but first, let's get a basic understanding of two elements of the vSAN ESA introduces that make it so special. First is our new patented log structure file system. This new layer is an innovative way to ingest incoming writes quickly, but with minimal overhead. It helps prepare the data and all subsequent changes to the data so that it's stored efficiently on flash devices, all while reducing the compute and network resources to do so. Next is our optimized data structure and I/O engine. This allows vSAN to store data and its associated metadata in an extremely fast and efficient way, which becomes especially important as flash devices increase in density. It is the combination of these two innovations that give vSAN the ability to store data with resilience and efficiency when using a single tier of storage devices, as well as an all-new native snapshot capability. Keep in mind, we didn't rewrite vSAN, rather introduced new patented ways for it to ingest and store data with supreme levels of performance and efficiency. Let's take a look at a new layer within vSAN that has been purpose-built to ingest writes in a fast and efficient way. This new patented log-structured file system is known as the vSAN LFS. Among other things, it allows vSAN to write many small I/Os quickly, coalesce them, and write a large block efficiently. At a high level, incoming I/O is compressed, coalesced, and packaged up with associated metadata, then written to a persistent, durable log, which lives on what is known as the performance leg of the object data structure. This allows vSAN to return the write acknowledgement immediately back to the guest VM to keep latency low. As new data accumulates in the durable log, the data payload from the previous log entries will be written to a portion of the object data structure known as the capacity leg. This will be in the form of an aligned full stripe write using RAID 6 erasure coding, the most efficient way to write data resiliently. The metadata will be sent to a metadata log for an additional period of time, which allows us to keep a large quantity of metadata readily available. But eventually, when the log fills up, it can be retained in an efficient B-tree structure and efficiently stored on the capacity leg of the object. The new vSAN LFS is one of the primary reasons how we're able to deliver RAID 6 level resilience and space efficiency at RAID 1 mirroring performance. With the popularity of NVMe-based storage devices, delivering the highest levels of performance while writing and storing data efficiently required several enhancements at the lowest layer of the vSAN stack, our Log Structured Object Manager, or LSOM. Its new design is built around a new high-performance block engine and key-value store that can deliver large write payloads while minimizing the overhead needed for the metadata. These enhancements were critical in allowing the new highly efficient upper layers of vSAN to send data to the devices without contention. But performance and efficiency aren't the only benefits. The new approach also removes the concept of disk groups, which eliminates a failure domain and makes adding, removing, or servicing storage devices easy and efficient. When using the vSAN 8 ESA, vSAN will distribute the data in a slightly different way than when using the original storage architecture. The ESA uses a new object format to store data in an object in two legs, the performance leg and the capacity leg. These are all contained within the same object and interact with the vSAN log structured file system LFS. This uses the same underlying distributed object manager to store the payload of data and metadata, but do so in a manner that delivers performance and capacity all from the same tier. It's a great example of how VMware integrated a new optional architecture within an existing codebase. Now let's take a closer look into what the vSAN Express storage architecture is and how it delivers all new capabilities for environments using modern hardware. In many ways, the Express storage architecture in vSAN 8 is so much more than just discrete enhancements introduced into a layer of vSAN. It allowed VMware to look at and rethink how data could be processed more efficiently in the stack. This is exactly what happened. We've moved some of the data services to the very top of the vSAN stack to reduce the resources and context switching needed to perform these tasks. For example, data is compressed and encrypted at the highest layer to minimize process amplification. Checksums are reused in an innovative way to minimize duplicate efforts. And finally, the vSAN ESA takes advantage of our new patented log structure file system to write data efficiently by ingesting a lot of small IOs and writing it as one large IO. It is the combination of these capabilities that make the vSAN Express storage architecture greater than the sum of its parts. Since the Express storage architecture found in vSAN 8 is an architecture optimized for today's hardware, it gives us the ability to build a high-performing storage pool using a single tier of storage devices. This means that all devices selected for use with vSAN will be contributing to the capacity and performance of a vSAN cluster. A user simply claims the desired devices on a host to create a single storage pool per host, which contributes its resources to the single data store for the cluster. The result is a simple user experience and better serviceability and availability of the storage devices that power a vSAN cluster. Simplifying administration was an important goal for VMware in the development of the Express storage architecture. We wanted to ensure that customers can have optimal levels of resilience that is space efficient and offers the highest levels of performance. Thanks to the assortment of architectural changes the ESA introduces, this is precisely what the ESA and vSAN delivers. Going forward, administrators can now simply use RAID 6 to gain enhanced levels of resilience and predictable levels of space efficiency, all without compromising performance. Storage policies have always allowed vSAN administrators to prescribe specific levels of resilience and space efficiency for VMs powered by vSAN. With the Express storage architecture in vSAN 8, we've introduced new levels of intelligence into our storage policy engine to make the data more space efficient, resilient, all while being easier to manage. When customers choose a RAID 5 erasure code policy, the ESA looks at the host count of the cluster to determine which one of two possible RAID 5 data placement schemes should be used. A new 4+1 RAID 5 data placement scheme spreads data with parity across 5 hosts and will be used in clusters with 6 or more hosts. A new 2+1 RAID 5 data placement scheme spreads data with parity across 3 hosts and will be used when clusters consist of 3 to 5 hosts. If the cluster host count is reduced below 6 hosts for a sustained period of time, the ESA will automatically adjust itself to the 2+1 RAID 5 data placement scheme so that the cluster maintains at least one spare host for rebuilding data in the event of subsequent failures. Since the vSAN ESA delivers the same levels of performance using erasure coding as it does with the RAID 1 mirroring policies, this means that customers will by default be able to store data at a more space-efficient level with a higher level of resilience that adapts to the size of the cluster. The Express Storage architecture in vSAN 8 allowed us to redesign how compression is implemented. First, new technologies are in place to improve the potential data reduction of the compression feature to as high as 8:1 compression ratio for every 4K block written. This is a 4x improvement from the original storage architecture. The new design of the compression feature in vSAN occurs in the upper layers of vSAN as it receives the incoming writes. We were able to not only reduce the amount of CPU effort needed to compress the data, but this also reduces the amount of network traffic, as any replica traffic is always compressed. This highly efficient design allows for it to be enabled by default, but for workloads already performing application-level compression, it can be turned off on a per VM or per VMDK basis through storage policies. Data encryption is a critical step in the effort of meeting security-based regulatory requirements. While the original storage architecture of vSAN provides discrete data encryption services for encrypting data in the vSAN cluster, the vSAN ESA takes an all-new approach to data encryption. It remains as a cluster-based service, but much like the compression feature in the vSAN 8 ESA, encryption occurs in the upper layers of vSAN as it receives incoming writes, but after compression occurs. This encryption step only occurs once, and since it occurs high in the stack, this means that all vSAN traffic transmitted in flight across hosts will also be encrypted. The result is improved security without compromise, as there is far less effort and overhead to perform encryption when compared to previous implementations. The Express Storage architecture in vSAN 8 makes deployments and operations of vSAN easier and more flexible. Our storage policies will allow administrators to use more resilient and space-efficient data placement schemes with no compromise to performance. And since the ESA eliminates the concept of disk groups, we've reduced fault domains that will allow for less of an impact when a device failure occurs, and improve the serviceability of these devices. Pair these enhancements with additional checks to ensure that the ESA in vSAN 8 is running on approved hardware, and this will provide a simpler management experience for our vSAN customers. With tremendous efficiency of the vSAN ESA, storage traffic can be processed through the stack at nearly device-level rates. This higher rate of processing IOs in a server means higher rates of IO traversing the network, which can potentially lead to the network being the bottleneck when running highly demanding workloads. To help accommodate for this, the Express Storage architecture in vSAN 8 includes an adaptive traffic shaping capability for vSAN IO traversing a network. This helps ensure that when network contention occurs, vSAN will properly prioritize VMIO over resynchronization activity. This can help deliver more consistent performance for these demanding workloads that may otherwise be saturating a network link. The introduction of the Express Storage architecture in vSAN 8 means that vSAN can now manage the data in new and interesting ways. When using the ESA, customers will have a new native snapshot engine that is highly scalable and efficient. vSAN environments will be able to create point-in-time states of data with a minimal degradation in performance of a VM, no matter how many snapshots are taken. The new native snapshot capability is integrated directly in vSphere and fully supports our broad backup partner community with continued support of VADP backup integration. With the vSAN 8 ESA, the native snapshot functionality is a foundational part of vSAN that will allow customers to be more agile with their data and introduce new use cases. Providing extensive health intelligence to a customer's vSAN environment is an important part of making vSAN robust and easy to use. In past versions of vSAN, customers who enrolled in the Customer Experience Improvement Program benefited from vSAN's cloud-connected health checks for early detection of issues. VMware recognized, however, that not all environments are able to enroll in CEIP. The vSAN Proactive Insights capability now allows customers who have a vCenter server connected to the internet but not enrolled in CEIP to receive the latest and greatest cloud-connected health checks. A two-tier system like vSAN relies on the caching and buffering tier to deliver the burst levels of performance for workloads. vSAN 8, under the original storage architecture, nearly triples the logical limit of the buffer capacity to a maximum of 1.6 terabytes, allowing for users to take advantage of these higher density, high performance devices to deliver improved levels of performance consistency to their vSAN environments. More capacity at the buffer tier means that workloads can run at the higher performing rate for longer periods of time, and it can reduce the strain on the value-based capacity tier devices, as a larger amount of working set data can reside in the buffer. Under a 5-disk group configuration, vSAN hosts can have up to 8 terabytes of write buffer capacity per host. Since a large percentage of our customers already use buffer devices larger than 600 gigabytes, these customers may see a substantial performance improvement when they move to vSAN 8 and enable the capability. Wrapping up, we see that vSAN 8 with Express Storage architecture delivers performance focused without trade-off on efficiency, better storage efficiency with reduced overhead, adaptive RAID 5 policies and native snapshots, and simplified serviceability. For more information about vSAN 8, be sure to go to core.vmware.com.